Last class you worked on this friction lab. We did the top part together, and then you worked on the questions. You went ahead and put a screenshot right here when you loaded up the sled and found a graph that looks something like this. You highlighted the top part, which is static friction, on your Notability doc, and then when you highlighted the kinetic friction part over here, you went like that, you hit view statistics, and then you could find the mean to get the force for that portion. What you're going to do today is you're going to scroll down, answer these questions here, make sure you're paying attention, part 2, to this information here about constant velocity and what does that mean when you're talking about forces and acceleration. Here's a sample problem. Make sure you try it. That'll get you in the right mindset for what you need to do below. Okay, so for this part down here, you're going to be varying the amount of mass that you're loading on top of the sled. So the procedure is here. And you want to make sure, again, that you connect your probe, that you zero it, you put the block on the table, and when you pull the force probe, that you're keeping it parallel to the table. Again, you're going to be highlighting and looking for this number right here that shows up in that stats box. Okay, so let's look at the data table. Over here is going to be your mass. Your mass is either going to be the block by itself, if that's where you start, or the block plus the mass that you put on top of it. Be careful with grams versus kilograms. Your masses are in grams. The block mass is written on the side of the wood, and that's in kilograms. So be very careful with this column. In the middle, you're going to calculate your normal force, which of course is opposite to the force due to gravity. So you're going to take mass times gravity for this column here. And then the n column comes from the highlighting that you're going to do on your graph. So you're going to go ahead and start maybe, let's say, with an empty block. You're going to drag the block. You're going to collect your data. You are going to highlight this area. You're going to click the statistics box. You're going to get this number, and you're going to put it here. Then you're going to go ahead and add another mass. Let me get back to graphical. Hold on. You're going to collect. I'm going to highlight. I'm going to view statistics. I'm going to come back over here and write it in, et cetera, et cetera, et cetera. So I would start empty and then add one mass, et cetera, on the way down. Get that information from that box. Okay, then moving on, you're going to go ahead and create a graph of your kinetic friction versus your normal force. So these. Make sure your best fit line is proportional, like the lab says. You're going to go ahead and follow through all of these questions. You're going to have to look back at your notes that we took in class and answer some questions here. And then part 3 is when you use the clay. Leave the clay in the bag. Leave it in the bag. It gets a little greasy. You're going to plop the clay on top of the sled. And my hint to you is you're going to use the car push lab, the process, the ideas, the math processes to help you with this unknown mass. So just like in the car push lab, where we took a whole bunch of data and we used that data to find the mass, you're going to do the same thing here. You're going to collect a bunch of data about dragging this clay on the sled, and you're going to use that data to find the mass of the clay. So the mass of the clay is the unknown mass. So I want to know your procedure. Write down your data that you get. You can include some screenshots there if you want. Make sure you talk about your unknown values and then try to find the mass. Then you can go up front and actually measure the mass and see what your percent error is. So there should be a scale in the front of the room, a balance for you to go ahead and measure.